Friends, welcome to MG Engineers Academy. In last session, we discussed about property number 2, that is multiplication by t. And based on this property, today we are going to solve some examples. But before going to examples, I wanted to clear one doubt which might occurs in your mind is that property 2. What is the property 2? Laplace of t f of t, right, is equal to minus 1 d by ds the bar of ds. This is the property number 2. Now if you want to solve the problem when power of t is 2 or power of 2 is 3, power of t is 4, power of t is n, then what you are going to do, because we have the value for power 1, right, t raised to power 1, then you are going to apply this term minus 1 up into d by ds f bar of s. Then what you will do when you receive such kind of examples? So it's a simple only. No, I will tell you the logic, no need to worry. You will get, or you have to use this formula, Laplace of t raised to n f of t, right, is equal to minus 1 raised to n t raised to n by ds raised to n to f bar of s. That's it. You have to only take the power of n here and derivative with respect to that power. Suppose if you have t raised to 2, then you are going to apply minus 1 raised to 2. Here n is 2, t 2 means derivative ds raised to 2. Right, means differentiating it 2 times. First you have to use first time and then second time. Similar way, if it is a 3, then you have to take here 3 and you have to differentiate it 3 times. Like that you have to utilize this formula or apply this formula. So I will keep this as it is. So I will move to the problems. First problem we are going to do. We are going to solve first problem t sine 80 upon 2a. T sine 80 upon 2a. What we have to do? Find out Laplace of t sine 80 by 2a, right? So what I will do here, I will take 1 by 2 outside, it's a constant, into t sine 80, right? Simple. We have Laplace of sine 80. It means we knew the formula for Laplace of sine 80. What is the Laplace of sine 80? A upon s square plus a square. So, but what is the our requirement? Our requirement is that t into sine 80 upon 2. We have to find the Laplace for this term. So, what I will do? I will mention by applying property 2. What is value we will get? Okay, let me tell you first property 2. What I have told you, Laplace of t f of t, or I can take t raised to n as well, no issue, minus 1 raised to n d by ds d raised to n upon ds raised to n into a bar of s, right? Here value of this power of t is 1, so you will get here minus 1 raised to 1 into d1 by ds1 into a bar of s. So you have to apply this formula here. Now how I will get is equal to 1 upon 2a, it's a constant, 1 upon 2a into, right, minus 1 by property 2. What is the property 2? Minus 1 d by ds a upon s square plus a square, right? Right. Now what can I do? 1 upon 2a into minus will be minus 1 upon 2a into, what I can do, I will take a term outside because it's a constant. So a into d by ds into 1 upon s square plus a square, right? Now I have to differentiate this term with respect to s. So we have one standard formula, d by dx into 1 upon x will be minus 1 upon x square. This is the standard formula for 1 upon x. So I'm going to apply the same logic. Before that, this a, this a will be get cancelled, minus 1 by 2 into 1 upon. I'm going to differentiate this term, s square plus a square bracket square, right? And we have to differentiate whole term. What will be the differentiation? 2s plus 0 because constant differentiation is 0. So what I will get 1 upon 2 here minus 1 because formula is minus 1 upon x square. So minus 1 upon s square plus a square bracket square into 2s plus 0 because differentiation of constant is 0 into minus into this term will be minus 2s upon s square plus a square. What I will get 2 to get cancelled. This minus will be plus. So we'll get s upon s square plus a square. This is the answer for t sine 80 upon 2a. Laplace for this is upon s square plus a square, right? Now we are going to example second. What is example second? T e raised to minus t cos of hyperbolic 2t. We are going to find a Laplace for t e raised to minus t cos of hyperbolic 2t, right? So we will go step by step. So first I will take this cos of hyperbolic 2t. Cos of hyperbolic 2t. We know we know cos of hyperbolic 2t. What will be the value? I will tell you one formula. Cos of hyperbolic theta is equal to e raised to theta plus e raised to minus theta upon 2. I am going to apply the same logic here. We know cos of hyperbolic 2t will be e raised to 2t plus e raised to minus 2t upon 2, right? So we are going to find the Laplace for e raised to minus t cos of hyperbolic 2t. So what I will get here, Laplace of e raised to minus t into e raised to 2t plus e raised to minus 2t upon 2, right? I will take 1 by 2 as outside because it's a constant. Laplace of e raised to minus t e raised to 2t plus e raised to minus 3, so 2t, right? Now 1 by 2. I'm going to multiply e raised to minus t inside the bracket, e raised to minus t into e raised to 2t plus e raised to minus t into e raised to minus 2t. Again, what I can do, 1 by 2 Laplace of e raised to t plus e raised to minus 3t. What I did, e raised to x into e raised to y, then we can simply add the x plus y. Yeah, right? So also we have standard formula for Laplace e raised to at will be 1 upon s minus a. If it is a minus, then you have to change the sign only, s plus a. That's it. So 1 by 2, 1 upon Laplace of e raised to at, s minus a. A here is 1 plus 1 upon s plus 3, right? So this is the Laplace of e raised to t cos of hyperbolic 2t. Now, what is our requirement? What we have to do? We have to find the Laplace for t into e raised to minus t cos of hyperbolic 2t. So we have received as of now the value for this term, right? This e raised to minus t into cos of hyperbolic 2t. Now we have to find the value for entire term, right? So what can I do? I have to apply property number 2 by applying property 2. What I can get? I will get, what is the property number 2? Laplace of t into f of t, right, is equal to minus 1 t by ds f bar of s, right? So 1 by 2 constant into minus 1 into t by ds of 1 upon s minus 1, 1 upon s plus 3, right? We have to differentiate this. 1 by 2 into minus 1 will be minus 1 by 2 d by ds of 1 upon s minus 1 plus d by ds of 1 upon s plus 3, right? So what I will get, minus 1 by 2. We have to apply the same logic here which we discussed in last. Derivative of d by dx of 1 upon x will be minus 1 upon x square. We are going to apply the same logic. What I will get, minus 1 upon s minus 1 bracket square, and derivative of this term will be, derivative of s will be 1, right? Plus same logic, minus 1 upon s plus 3 bracket square, and derivative of s plus 3 will be 1 plus 3 derivatives will be 0, so 1. What will be next? Minus 1 by 2 minus 1 upon s minus 1 bracket square. This minus, this plus minus 1 upon s plus 3 bracket square. This is the answer. If you want to simplify it further, you can simplify it, or you can keep it as it is, Laplace of this is the value of e raised to minus t t into e raised to minus t cos of hyperbolic 2t. This is the Laplace for the equation. Now we are moving towards example 3. This is example 3. T sine cube t. T sine cube t. What we have to do? Find a Laplace of t sine cube t. We'll go one by one. First, we are going to identify Laplace of sine cube t. Okay. In 11th and 12th standard, we have one standard formula. Sine cube theta is equal to 3 sine theta minus sine 3 theta by 4. We are going to apply this formula here. So what I will get? Laplace of 3 sine t minus sine 3t upon 4. Right? I will take 1 by per constant. Laplace of sine 3 sine t minus sine 3t. What I will get? 1 by 4 outside. Now we knew value of Laplace of sine at will be a upon s square plus s square, right? So I'm going to apply the same logic here. What will be Laplace for 3 sine t? 3 is the constant. 3 into a is 1 here upon s square plus 1 square is 1 minus sine 3t. What will be the Laplace for sine 3t? It will be a upon s square plus 3 square 9. I will get 1 by 4 3 upon s square plus 1 minus 3 upon s square plus 9. If I take 3 outside, then I will get 3 by 4 1 upon s square plus 1 minus 1 upon s square plus 9. This is the value of Laplace sine cube t. Now what we have to do? We have to find Laplace of t sine cube t. So it is in the form of by second property. I will mention by applying property 2. What I will get here? 3 by 4 into minus 1 d by ds of 1 upon s square plus 1 minus 1 upon s square plus 9. Right? How did I write this term? By applying property 2. What is property 2? Laplace of t f of t will be minus 1 d by ds a bar of ps, right? I applied the same logic here. So what I will get? Minus 3 by 4 d by ds of 1 upon s square plus 1 minus d by ds of 1 upon s square plus 9. What I will get? Minus 3 by 4. I'm going to apply the formula. Derivative of d by dx of 1 upon x will be minus 1 upon x square. So I'm going to apply the same logic here. Minus 1 upon s square plus 1 bracket square, and derivative of this s square plus 1 will be 2s plus 0, right? Minus 1 upon s square plus 9 bracket square into derivative of this term will be 2s plus 0. So minus 3 by 4 into this minus 1 plus 2s will be minus 2s upon s square plus 1 bracket square minus into 2s will be minus 2s upon s square plus 9 bracket square. If I further simplify it, what I will get minus 3 by 4 into minus 2s upon s square plus 1. This minus, this minus, this minus and this minus become plus 2s upon s square plus 9 bracket square. So after further simplifying, what can I do? I can take 2s common and I will multiply this minus to inside term. So I will get 3 by 4 into 2s. If I multiply this minus to the inside bracket, this minus will be get plus 1 upon s square plus 1 bracket square. This plus and this minus will be minus 1 upon s square plus 9 bracket square. After further simplification, what I will get 2 to 4, I will get 3 by 2s, right? If I cross multiply this term, what I will get s square plus 9 bracket square minus s square plus 1 bracket square upon s square plus 1 bracket square s square plus 9 bracket square. So I am not going to expand denominator term. So what can I get? 3 by 2 s 4 plus, I am going to apply the formula here. What is the formula? A plus b bracket square will be s square plus 2ab plus b square. If it is a minus b bracket square will be a square plus, sorry, a square minus 2ab plus b square. I am going to apply this logic here, right? So s square s raised to 4 plus s square into 9 into 2 18 18s plus 81 minus s raised to 4 minus become plus minus. Okay, let me do not confuse you, so I will write minus s raised to 4 plus 2s square plus 1 upon this term s square plus 1 bracket square s square plus 9 bracket square. After simplifying it, what I will get 3 by 2 as s raised to 4 plus 18s plus 81 minus s raised to 4 minus 2s square minus 1 upon s square plus 1 bracket square s square plus 9 bracket square. After simplifying it, what I will get 3 by 4 into s. This s4 and this s4 will get cancelled. 18s square minus 2s square will be 16s square. 81 minus 1 be 80 plus 80. 16s square plus 80 upon s square plus 1 bracket square s square plus 9 bracket square. That's it. This is the answer for T sine cube t, right? Right. This was the example which we learned today. Now I'm going to solve the last example. Let me see if I have the space here. Okay, I will take this side. Next example. What can I? Fifth example. One, the fourth example. T into e raised to 3t into sine 4t. Right? Okay, let me read down it clearly. T e raised to 3t sine 4t. What I have to do, I have to find the Laplace form t into e raised to 3t into sine 4t, right? So Laplace of t e raised to 3t to sine 4t. What we have? Laplace of sine 4t. What we will have? We have standard formula for Laplace of sine 8t is a upon s square plus a square. So here I will get 4 upon s square plus a square will be 16. Now first I have found the value for sine 40. Now in second what I will do, I am going to find the value for this term. Where is that? 3t, sorry, e raised to 3t sine 40. Laplace of e raised to 3t into sine 4t. We knew the value for sine 4t. Now here we have e raised to 3t into sine 4t. So you can remember this will fall under first shifting theorem. And what is the first shifting theorem? Laplace of e raised to 8t f of t will be f bar of s minus a, right? So by applying first shifting theorem, I will directly write the term 4 upon wherever s is, I have to write s minus a, and s minus a will be s minus 3, right? So s minus 3 bracket square plus 16. If I simplify it further, 4 upon s square minus 3 to 6s plus 9 plus 16. After further simplifying it, 4 upon s square minus 6s plus 25. Now, what I have received as of now, Laplace of e raised to 3t sine 4t. This is the value for this term, s square minus 6s plus 25. Now, what is our requirement? We have to find the Laplace for this term, right? And what I did, I have, as of now, I got the value for this term. Now I'm going to find the value for this entire term. How I can find that? Now I am going to apply first shifting theorem, sorry, second property by property 2, by property number 2. What is the property number 2? Laplace of t f of t is equal to minus 1 d by ds to f bar of s. So I am going to write 4 into minus 1 into d by ds of of 1 upon s square minus 6s plus 25, right? How we are going to solve this? What I will do, I will derive it by 4 into minus 1 will be minus 4 d by ds of 1 upon s square minus 6s plus 25. I'm going to apply the same formula here. D by dx into 1 upon x will be minus 1 upon x square minus 4 minus 1 upon s square minus 6s plus 25 bracket square into derivative of this term. What will be derivative? 2s minus 6, right? So what I will get? This minus become plus 4 into 2s minus 6 upon s square minus 6s plus 25. That's it. This is the answer for term t e raised to 3t sin 4t. So that's it. Now we have discussed in today's session the problems related to property number 2. Now in next lecture we are going to discuss property number 3. Let's see. So if you have any doubts, please comment me in the box. Thank you.